Are you a citizen of Lethbridge, Alberta? Are you tired of strong winds blowing over your garbage cans, making a mess on your streets and causing litter to go everywhere? Well, I'm happy to report that we have a solution for you. Our Year 1 engineering team at UBC Okanagan has been working meticulously, analyzing many different designs, and we believe that we have come up with the best possible fix to your problems. Introducing the sandbag method.
Using a program SOLIDWORKS, we are able to construct a simplified replica of the recycling bin used in Lethbridge. In the program, we ran simulations to determine the force the bin is experiencing at different wind speeds. If you look at the 120 km/h wind study here, you can see a force of 500 newtons, and that's causing a torque of 310 newton meters. The side of the trash can is wider than the front. The base is also narrowest side to side. In the photos, you can see the bins mainly being blown over by the side. When the cans are put out at the street, they're typically building in structures that block some of the wind coming head on to the bins. For this reason, we mostly focused on side-to-side stability. Also here, when we did simulation with the wind coming from the side, 60 km/h, we can see a torque of 77.5 newton meters, and when we have the 60 km/h winds coming from the front, we can see a torque of 60 newton meters. For our solution, a sandbag will be placed inside a net and tied to the bottom edges of the bin. 4 holes can be drilled in the bottom side of the bin. The ropes can then come out through the holes and be tied with a washer on the end here. Once we start considering higher winds, a weight won't be enough. At 80 km/h winds, we would need a weight of about 60 pounds in the bottom of the bin. The weight required continues to go up exponentially as we reach winds at 120 km/h. Metal pieces are added to the bottom to make the base wider and support side-to-side winds. Rubber feet are also added to the bottom of these metal pieces. In this cross-sectional view, you can see this metal piece here acting as a spacer. Here we can see a strength test done in SOLIDWORKS. It basically shows the strain that this section of the beam is facing when half the weight of the bin in the sandbag is pushing against it. This stress would occur at over 120 km/h winds. As you can see, the max yield strength down here is still more than the stress we're experiencing on the beam here. The displacement is 3.5 millimeters measured at the end here, and this shouldn't be of any concern.
Here's a SOLIDWORKS assembly. Inside you can see the sandbag to reduce the tendency to flip when it is empty under high crosswinds. Here you can see the holes for the ropes to hold the sandbag down when it is flipped upside down above the garbage truck. And here you can see our metal supports. They're made of carbon steel because it's strong, cheap, and can be painted to resist corrosion. And you can see rubber feet to resist sliding on ice.
We will be using 6 ounces of zinc phosphate primer to prolong rusting. This costs $7.25. A 35-pound sandbag, which costs $6.35. We have 11.46 pounds of carbon steel for a wider base, which is $5.44. To tie down the sandbag, we are using $4.50 worth of rope. The total cost of this design is $23.54.
It is important to note that holes drilled in the bin will weaken it. These holes give a point where the bin will crack. So if you living somewhere where you think you'll only be experiencing 60 km/h winds, you can get away with just having the sandbag in the bottom of the bin, and then you will have 4 less holes to drill. But if you're experiencing those 120 km/h winds, then you will need those extra metal support beams, and you'll have to accept a maybe shorter length of life for the bin.